All right, hi guys. So in this lesson, we will cover server cooling technologies. Why don't we just get started? Now, with the development of high-performance data centers and cloud computing, network servers also face a problem of load and centralization. So this undoubtedly brings challenges to server cooling, while also promoting the development and progress of server cooling technology to a certain extent. Now, there are several modern cooling technologies, and we're going to now take a look at the development and application technology of what we call server cooling. So from the past up until now, server cooling technology has also been developing and evolving. It's gone through three distinct stages. There was the budding period, probably from 1965 to the year 2000. The development of mainframe computers and network servers was in its infancy, so traditional air cooling technology was pretty much what you'd get. However, liquid cooling technology had already appeared at the time, mainly by placing electronic components in a non-conductive cooling liquid. The cost of heat dissipation was quite high due to the limited technology of material fabrication. It reached its mature period probably between 2001 and 2009. So with the rise of the internet era, the demand for network servers began to surge, and the cooling requirements became higher and higher. The traditional air cooling and liquid cooling technologies could no longer satisfy the demand, so intelligent control technology for fans appeared. And then we get to the high-speed development period since 2010. The development of cloud computing, as well as data centers, while these servers need to be placed in a limited amount of space, and heat dissipation becomes the top priority. So it's at this time intelligent control technology and new heat dissipation materials are the focus of the IT team, and it brings a new vitality to the heat dissipation field. You may likely already know it's critical to keep the server cool while it's running. Excessive temperatures can cause it to crash and, in severe cases, result in lost data and service interruption. There's actually a temperature threshold that starts to affect server network performance when the temperature rises above 70 degrees Fahrenheit. It's at this point the computer connected to the server will also have some problems affecting its operating system. If the temperature continues to rise to a certain level, it's going to cause some serious problems, like fire, power outages, all kinds of stuff. In the continuous development and exploration of server cooling technologies, several types of server cooling technologies have also emerged, including free cooling, liquid cooling, thermal sensor, smart control, and server cabinet cooling. So air cooling, what we call free cooling. Well, its purpose is to guide the direction of the wind, right? Blowing the cold air to the heating element or, extracting hot air from the heating element to achieve server cooling. There are two distinctly specific ways. The first is the fan. So above all, we have to install a large number of cooling devices on the server motherboard, yeah? And then install the fans above and below the server cabinet. When the cooling device dissipates the amount of heat on those electronic components, the heat's going to be taken away by the airflow generated from the fan, thereby achieving a certain amount of cooling. Now, the second type is the cooling air duct. The main method here is to place the air duct cover on the electronic components of the server motherboard. The front section is connected with a fan to form the inlet, and the rear end is placed at the rear air outlet of the motherboard to form a convection area. Right now, at the same time, this blocking part, the sealing part, and the dividing part form corresponding air ducts. When the heat is located in the air duct, it can be carried away by the airflow in the air duct. Liquid cooling will refer to the method of heat convection or heat conduction, mainly through the immersion or flow of liquid to take heat away to achieve server cooling. There are basically two common cooling methods: immersion and liquid cooling loops. So it's immersion, loading a server with a large number of liquid coolants, such as fluorinated hydrocarbons. See, the server chips are immersed in coolant liquid, and steam is created when the liquid coolant and the condenser carry heat away from the chip. The steam will circulate with the coolant to take away the heat according to a certain circuit, and after cooling by the heatsink, it will become liquid and merged into the coolant. The liquid cooling circuit is where the heating elements on the server are formed into a single unit, and the heat is dissipated through the water cooling sleeve. Fixed piping. First, the heat receiving part, the second part, heat receiving, and then a large pump are provided in the server case. The cooling liquid can be circulated to each monomer independently, and after passing through each part of the facility, the heat will be transferred to the casing. Then finally, it's released into the air by the natural heat dissipation of the casing or the cooling fan to complete that cooling circuit. So a thermal sensor is installed on the server, and the heat is transferred to the outside to achieve this server cooling effect. The principle of thermal sensors is to transfer heat to lower temperature objects. So that includes heat sinks, cooling plates, and semiconductor plates. The semiconductor uses two conductors to form a circuit. When the direct current passes through, one end is used to release heat, and the other one is used to absorb heat. If the current direction is reversed, the heat absorption and heat release will also be reversed. Smart control has the ability to use sensors to detect the temperature and load inside the server, and then obtain temperature parameter information through the sensor, adjust the flow of fans or coolant to the control circuit, and realize a smart server cooling mechanism. Its working principle is that when the cooling fan is working, it guides the airflow through the CPU and the other server components, and the controller will control the cooling fan to adjust the temperature according to the information sent by the power supply unit and the temperature sensor. Now, one of the most straightforward ways to cool a server is to leave enough space to ensure good airflow among server racks. Server cooling is accomplished by using fans, fan panels installed in the cabinet, or even air conditioning. The temperature inside the cabinet can be affected by the door opening, size, and the type of components. So you can choose an open or perforated door server cabinet with more space to accommodate a different number of server racks, maintaining a distance of at least 1 to 2 inches between the equipment and the front and rear of the cabinet. That way we achieve airflow. So to sum all that up, the problem of server cooling has always been a very important issue that deserves a lot closer attention. The development of cooling technology needs to keep up with our needs of our data center servers, but from the current point of view, various technologies for server cooling are becoming more and more mature. All right, so that's it for now. You've got a few new server cooling technologies under your belt. Why don't you stick around, and I'll see you in the next lesson.